Hello, in this video I will do an SAT practice exercise on linear inequalities in one or two variables, and these are very fairly simple ones. So let's begin. So on the new digital SAT, you may use the Desmographic calculator. So that's why I have it up on my browser, just in case. So number one says, what is the integer of the value of x that satisfies given inequality? You're just gonna have to solve for x and figure out which one is the correct one. So that's what I'm gonna do. So what I want to do first is before I move things around, always check if you can always make sure if you can collect like terms on the left and right. So on the left, oops, here's the left, and then here's the right. Can we combine like terms? No. So what you're gonna do is either get all the letters first on one side or the constant. It really doesn't matter what you do first. So if I decide to get all the x's on one side, I'm gonna have to add 2x, add 2x. This cancels. And then negative 7 plus 2 is negative 5x plus 6 is greater than negative 9. And then solve for x, so you're going to subtract 6. Subtract 6. Negative 9 and negative 6 is 10, 11, 12, 13, 15, 15. Okay, and then you're going to solve for x by dividing both sides by negative 5. Divide both sides by negative 5. And when you divide by negative, you gotta flip it, so it's going to be less than 3. So we need a number that is less than 3, not equal, because it doesn't have that straight horizontal line. So any number less than 3 will do. So it looks like 2 will be the one, right? So 2 works. So that's what I'm going to use. Okay, question 2 says, which point in the xy plane is a solution to the given inequality? 8x minus 13y is greater than or equal to 100. There is technically 3 ways you can do this. You can just put this in Desmos and figure out which one is the boundary. So if I do that, there, here I did. I already put it in. And so the shaded region is what we can use. The non-shaded we can't use. So we can't use anything above the shaded region. And yeah, so what we're gonna do is look at our points. Can we use the point 3 comma negative 5? Here's 3, 2, negative 5, 2, 3, 1. No, it's not in the shaded region, so we can forget about that. Can we use the point 4 comma 13? Here's 4. No, 4 comma 13 is way up there. It's not in our region. What about 10 negative 2? That looks good. Here's 10, 1, 2. Yes. Do you see it? Here, let me zoom in a bit. Here, 10 negative 2, 1, 2. It's right here, right? That is definitely in our region. So, yeah. But if you want to check again, let's look at all our choices. Can we use 15 comma 2? Here's 15, 1, 2. It's wait, no, because 15 comma 2 is right here, right? So yeah, we can't use that one. Okay, the other way we could solve this is you can literally, if you didn't want to use Desmo or if you don't know how, you could test each choice and figure out if this statement makes the inequality true. So for example, 3 comma negative 5, here's your if the x and here's your y. So it's going to be 8. I'm going to test that point. 8 times 3 minus 13 times negative 5. Is that greater than or equal to 100? Let me see. Times 3 is 24. 65. 89. Is 89 greater than equal to 100? Completely false, right? What about 413? So let's check it. So it's times 4 is 32. It's -7. That's obviously not greater than 100, right? That's very false. Let's try 10 comma -2. That is 54. Wait, oops. I forgot about -2 here. That's why it's off. 80. And then it's- I get 106. Is this statement true? Is 106 greater than equal to 100? Definitely yes. So that's why I use the point C. What's the third way we could do this is if you really want to go old school, you can graph this, right? So let's pretend you didn't have, you could graph this even without a decimal. That's how we did it way before decimal. So how would I graph this? Um, well, I know you got to figure out if it's a solid or dash. It's definitely solid because this has an equal sign, right? If it was greater than or less than, it would be dash. So I know it's solid, and what I would do is you can do to graph this, you can do two ways. You can solve for y and do the rise over run, or you can find the x and y intercept. That's what I'm going to do. Well, first, let's make it as an equation to make our life easier. So let's find the x-intercept. And find the x-intercept for any graph and simply set y to 0 and solve for x. It's 12.5, so you have an x-intercept at 12.5 off of 0. And then the y-intercept is you set x to 0, so for x. I mean, solve for y. Get like -7.6 or really like -7.7. So you have a y-intercept at 0, -7.7. Okay, so if you kind of draw it on the contingent things, my x-intercept is 12.5. Here is 12, there's 13, so 12.5 should be right in the middle. And then 0, comma -7.7 would be down here. Um, 6, 8, -7.7 would be right about here. And we said it's going to be solid because it has an equal sign. So you're going to put a little solid line connecting these two dots. And then how do we do the shading? So for the shading, what you do is pick a point that the line does not go through. I strongly recommend the origin because it usually never goes with the origin. 0, 0. So what you're going to do is plug in that 0.00 back into the inequality. And if it's true, shade on that region. If it's false, you shade on the other, right? So let me plug that back in. Okay, so this zeroes out. So it's 0 greater than 100. Is 0 greater than equal to 100? I'm not even sure. So put it on another line. Here's 100, here's 0. Is 0 greater than 100? That's very false, right? So what we do is we pick the point 0, 0, said it's false, so you're going to shade on the other side. Okay. So as you can see, 3, 5 is not in our shaded area. 4, 13 is not in our shaded area. 10, 2 is definitely in our shaded region. So that's how I got answer C. Okay, so I just taught you 3 ways to solve this problem. Desmos, which is probably the most fast and efficient way. Um, Testing each point, chug and plug, and see if the statement is true. Or you can go old school and graphic by hand and figure out which of these points are in our boundaries. Okay, let's move on. Okay, so question 3 says Harold is a car salesman. He takes home a monthly salary of 4,950 plus 650 commissions for each car sold. Harold is planning a vacation that costs exactly 9,000 and wants to cover the cost with one monthly paycheck. What is the minimum number of cars Harold needs to sell? What is the minimum number of cars Harold needs to sell to have enough money to afford his vacation? So this is definitely an inequality. So he said that he makes automatically each month he makes an automatic salary of 4,950, right? And then he has a 650, he gets paid 650 per each card sold. So that's like 650 times C, right? For the commission. And then a vacation that costs 9,000. So what it would be the appropriate inequality symbol? A vacation costs 9,000, not so it's nothing less than 9,000. So it has to be obviously greater than or equal to 9,000. Okay. So I mean, you could, yeah, that I would solve for C. So if I do that, I would subtract 4,950, 4,950 sides, get 650C is greater than or equal to 0, 50, and divide this by 650. So 4,050 divided by 650 is 6.2. Okay, so obviously you can't have a 6.2 cars, right? So it's either 6 or 7, right? We can only use whole cars. So let's plug in 6. If it's greater than or equal to 9,000, then we can use 6. And if it's not, then we'll use 7. So 650 times 6 is 0. Is that greater than or equal to 9,000? I get 8850. That's very false, right? This is not greater than or equal to 9,000. So I think it would have to be 7, but let's just double check. Let's plug in 7 back into our inequality. Oh, yes, it's definitely true. It's 9,500 greater than or equal to 9,000. So yes, it would have to be 7 cars just to make enough for his one that vacation he wants. Okay, question 4. Which point is a solution to the inequality? So, I mean, sure, you can test each one. Uh, it's just like the first one. You can put it in Desmos. You can test each point, uh, right? Um, yeah, let's see. Let me find, let's see what happens if we put in Desmo. Okay, so here's our graph, and let's look at our each points. Is 0, 12 in our boundaries? Yeah, it is. But here's the thing. We can't include it. We cannot. It's not in our boundary. Why? Because it doesn't have an equal sign, so it's not included. So you see how this has a dash? This doesn't have an equal sign. If it was an equal sign, then yes, you can include 0, so it will definitely be in our boundaries. But no. What about 5, 9? No, 5, 9 is right here. See how it's above the dash line? So definitely no. What about 10, 11? Yeah, it's 10. Here's -10. So -11 would be right here. So yeah, it would definitely be in our boundaries, right? You see that? 10, 11. Yes, like right here. So that would be true. Okay. So what's the other way? You can test each point. So um, let's see. Y is 0. Oops, not Y is 0. If I test the point A, here's your X, here's your Y. So it's going to be -12 is less than 2/5. So -12 is this a statement? Is this a true statement? -12 less than -12? No. If it had an equal sign, yes. Um, what about 5, 9? Let's see. Here's your X, here's your Y. So it's -9. Let's see, this is going to be cancel those two. Four. It's 2 minus 12, -10. Um, is -9 less than -10? So if I'm not sure, put it on another line. Here's -10, here's -9. Is -9 less than -10 false, right? That is definitely false. Uh, and then let's try 10, equals y is -11, x is 10, is 12. 10 divided by 5 is 2. 2 times 2 is 4 minus -11, and then it's 4 minus 12, -8. So if you print out here's -11, and here's -8. Is -11 less than -8? Yes, it is, right? I mean, what is it? It's true, right? Here's -11, here's -8. It's definitely um, smaller, right? It's more negative than -8. So yeah. Okay, so that's four. So and the other way is graphing it the long way, but uh I'm not gonna do that one. I mean, I'm not gonna do that method because yeah. Question five says, which of the following is a value for x that satisfies the inequality? So you would just have to solve for x. That's it. So I'm going to add 2. You get 3x is less than n plus 2 is 12. And divide this by 3. You get x is less than 12 divided by 3 is 4. So we need a number less than 4. It would have to be 2, right? So add 2. Okay. So that's right. First part, let me just, and then score. Let me just see my results real quick. Okay, so it looks like we got all of them right. So there's a second part, so let me go over that. Okay, let me if I can zoom out. I'm zoomed in a bit, so I can zoom out a bit. So I'm gonna start. So this is the second part of the linear inequalities in 1 and 2 variables easy problems. So let's just continue. Here, should I zoom in? I don't know. Let me just preview. Okay, so question one says, which value of x satisfies the given inequality? So what I would do is try to solve for x. So what I would have to do is first isolate x. So first I would have to get rid of that 6. So do you see the 6? I'm going to get rid of it by subtracting 6. Now be careful. We have to do it. We have the left, the middle, and the right. You got to do it on all sides, all three sides, right? So you get 2x is less than, and then 6 minus 6 is 0. And then on the left, right, -4, -6, and 7, 8, 9, 10, -10. And then what I'm going to do next is get rid of the 2 by dividing both sides by 2. We get x is less than 0 divided by 2 is 0 is less than, and then -10 divided by 2 is -5. Okay, so what does this mean? It really means if you put in another line, here's -5, here is 0, you're going only in these boundaries. So any number between these boundaries is fine. Anything outside, like here, is not fine. So look at A. Is -7 in our boundaries? No, -7 is right here. It's outside. Is it B -5? No. Um, we can't use neg. You can't use -5 completely because it doesn't have that equal sign. So no. What about C is -4? Uh, yeah, -4 is in our boundaries, right? Right here. That is in our boundaries. So yes, definitely. Is it? What about zero? No, zero's way off. It's too big, right? Or not too big, but we cannot include zeros because it does not have that equal sign. If it did, then yes, we could. So let's see. Question two, which of the following inequalities has the same solution set as the inequality? So let's just go ahead and try solving for x. So I'm going to subtract 2 for both sides. You get -3x less than 14 minus 2 is 12. And then divide this by -3. Now be careful. Remember when you divide by negative or multiply by negative in an inequality, is you got to flip the sign so it's going to be greater than, right? -4. And which of these are equal? Which of these inequalities are equal to x is greater than -4? A, if I divide both sides by -3, no, because that doesn't give you -4. Is it B? If I subtract 1 both sides, get x is less than -4. No, you want something slightly larger, right? What about C? If I divide this by 2, you get x is greater than -8 divided by 2 is -4. Bingo, right? X is greater than -4. I mean, X is greater than -4. That's what we have. So it has to be C. Question three, which of the following important forms is a solution to both inequalities? So you could put this in the Desmo. I'm gonna try to somehow solve for it or get one of the letters. But when I did this, I noticed one thing. So if I tried to get rid of I don't know, let's try to get rid of the x's. So I would have to multiply the first entire equation by 2. So 2 times 2 is 4x. 2 times 3, 8y is 6y. Greater than or equal to 2 times -12 is -24. And then over here, you get -4x, -6y is greater than 20. So this zeroes out, so you're left with 0. Is no, none of this is off. That's how you know, that's a big clue. That is no, none of these solutions will work, right? Um, like, and if you don't believe me, try it out, but it's going to be no solution. So if I even tried the first one, you would have to test it here and here. You gotta do it in both, right? So it'd be 2 times -9 plus 3 times 2 is greater than or equal to -12. 2 times -9 is -18 plus 6. That's -12. That's false, right? -12 is greater than or equal to -12. Oh wait, that is kind of true. But if you put it in the second one, this is where it's all off. 6, and -6 times 2 is -12. Is 24 greater than 24? No, right? It's false. If it had an equal sign, then yes, maybe. If, yeah, that one. So I know this isn't gonna work out. It didn't work out. I know A won't work out. I mean, I already based on my like I already did this problem, but if you're not sure, try it out. both inequalities, and if its statement is true, that's how you know it works. But those don't work. So I tried it out before. But so yeah, D is correct. There would be no points that satisfy both inequalities. Um, and yeah. Okay, question four. The value of -6 is the value for x that satisfies inequality. 10 is less than x plus 17 is less than k. What is the possible value of k? So yeah, it's 10 less than x, 17 is less than k. So what I would do first is get x by itself. Do not plug it in yet. So get x by itself. So I'm going to subtract 17 from both sides. Subtract 17 from both sides. So you get x is less than k minus 17. Less than, what's 10 minus 17? -7. And then what I'm going to do is I'll make plug in x. Then I'm going to plug x for -6 for x, right? So go back to here. I don't even think we don't care about this -7 because we only care about this inequality because it has that x. So I'm going to replace x with what did I say? -6. So it's -6 is less than k minus 17. And then add 17 to both sides. Get 17 minus 6 is 11. 11 is less than k. Now, this is backwards. It's really k is greater than 11. So anything larger than 11 will work. I think it's going to have to be 12, right? Yep. And that is correct. Well, that's one. So question five says, how is inequality 2x plus 2y is less than or equal to 16? If a comma a is a solution to the given inequality, what is the greatest possible value for a? So they're saying that you see this a is looking coordinate x and y. So if I plug that back into this inequality, it'd be 2 times a plus 2 times a is less than or equal to 68. What's 2a plus 2a? 4a is less than or equal to 68. Divide this by 4. You get a is less than or equal to 68 divided by 4 is 17. And then if you put this in, because they want the largest, so you kind of put it in the number line for 17. It's going to be a dark circle and it's going to be less than or equal to. So based on this inequality, what's the largest? It's 17, right? That's the largest it can go and it's included because it has a dark circle. So yeah, definitely 17. Okay, so let's end in score. Okay, it looks like we got it all right. I just will always want to double check because I would not want to give you a wrong answer, right? Okay, so that's wraps it up for this video. So I am going to stop here.